Sponsored by True Tech Tools. Quality tools, essential support. TrueTechTools.com.
So I've been checking the air conditioning here at the cabin that we're renting, and using the AAB TS100, basically a little dongle temperature sensor that'll give you a lot of air side information. And I didn't want to be too intrusive, so I'm not going to be using my pressure sensors, but I also brought the Sporlan Smart Tool. Was going to go ahead and take the line temperatures and the air temperatures and see, just see how that system performance data may help us get an idea of how well the system's actually operating. The air side is pretty telling, but let's just finish out the picture here and take my suction line temperature in cooling and my liquid line temperature as well. We're running R410A refrigerant. We'll give the numbers a few seconds to balance out. As I had mentioned, the condenser coil appears to be fairly clean. Yeah, it's not bad. So, you know, it's definitely had some service done to it. Ambient temperature, it's a good question. I haven't paid attention because we don't have any internet access out here. And I haven't found, I guess I could take my temperature sensor outside, couldn't I? Anyway, the system has been running for quite some time now, trying to come down from 75 to 72. And right now we've got an 80.6 liquid line temperature and a 53.1 degree suction line temperature. If we take that information and we go back and we visit the air side information, we had a return air temperature of 67.5 with a relative humidity of 66. And then on the supply side we had 51.6 and a relative humidity of 87%. What we're going to go ahead and do next is take an ambient temperature with the TS100, as well as punch this information into the iManifold app and just see what we get out of it. Let's double check the pipes again, just for updated pipe temperatures. 80.6 and 52.7. So I brought the TS100 outside to get my ambient, and it was pretty cold, and it is sweating a little bit, but my current information says that I've got 100% humidity at 59.4 degrees. So we're going to let this balance out a little bit here before we worry about the reading that it's giving us. Can I hang it somewhere? Yeah. So we're going to take the numbers we had collected so far and go ahead and dump them into the app. The profile for this piece of equipment is a heat pump running 410A. Does have a standard TXV, though the unit is not, the condenser is not looking for a target subcooling. And crap, I don't remember the model of the air handler. It's a 31, wasn't it? I think it was a 31. So it's a 2.5 ton air handler, which gives us at that point a high efficiency evaporator on a 2 ton condenser. Nominal tonnage is 2 tons, and so now we have a profile. We're going to start by inputting the air side measurements. My return air
was 67.5 degrees. The relative humidity of the return was 66. The supply air was 51.6 degrees, and the relative humidity was 87. Go in here, we got nominal tonnage, and we don't have pressures yet. Suction line temperature was 53.1. Liquid line temperature was 80.6. And we're going to change that suction because it dropped a little bit, 52.7. We don't have an outdoor ambient as of yet. It's still showing 100% relative humidity and only 66.6 degrees. At that point, we definitely don't have any automatic airflow calculation because my return air temperature is below 69.4. But that does give us a 16 degree temperature split and a target suction pressure of 113. So for grins, since we don't know what the pressures were, we're just going to input what the target pressure should be and see how that gives us a superheat and subcool. If our suction pressure is in the vicinity of 113 psig and our suction line temperature is that 52.7, then we've got a 15.67 degree superheat. We don't have a target head pressure yet, but let's see. It's more than 68 degrees out here. Quite a bit more, I'm sure. What does that say?
$79.
79 degrees outside based on the old mercury thermostat. 79. That would give us a head of 314 psi, and if we are correct there, that would give us an 18 degree subcooling. 18 degrees of subcool is not necessarily ridiculously overcharged, but it is a little high based on the old rule of thumb that says 10 to 15 degrees of subcooling. And most of the time these old train systems were a 10 degree subcool when the condenser was actually matched up with a unit that looked for subcooling rather than a condenser that looked for a piston. But anyway, that gives us a little something, and since my temperatures are a little low, I'm not getting my tonnage or my BTU calculation. The only other thing that I probably could have brought would be the ABM 200, which I could have done per register airflow to come up with an idea of what my airflow was. But I didn't bring it, so this is what we've got to deal with. Anyway guys, thanks for watching, and we'll see you on the next one. Don't forget, you can use coupon code RARVID and get $10 off your purchase at TrueTechTools.com, or the coupon code RARIDVM for $10 off your IDVM 510 meter. Thanks to the 100 Watt Vipers for allowing me to use their music also. You can search for my Facebook group at HVAC with Stephen Rardon, or follow me on Twitter at Juvenile77. Thanks for watching.
One man, your heart is heavy. You got troubles on